Okay, in this video we will talk about some of the problems related to insertion short, okay, which I have taken from Introduction to Algorithm books by Cormen. Okay, so that's why I just given the problem numbers as well, okay, after each and every problem, and I just picked up some important problems from there. Okay, hopefully this will be helpful. Okay, so we will start with the problem number 1. So what it is saying basically is, suppose we are comparing implementations of insertion sort and merge sort. Okay, I know still not discussed the merge sort algorithm, so but this problem is, for to solve this problem you do not need to know what merge sort is. Okay, so a merge sort on the same machine. Okay, now for inputs of size n, the insertion sort runs in 8n squared steps, if you see it here, while the merge sort runs in 64n log 2n steps. Okay, now for which values of n does the insertion sort beat the merge sort? That means we're talking about the we are talking about the steps, the number of steps the insertion sort algorithm took, and the number of steps the merge sort algorithm took, right? So if we just need to find that how the insertion sort beat the merge sort, that means insertion sort will be taking lesser steps compared to the merge sort, right? So essentially, so if I just try to answer this problem here, okay, I will try to make it bold. Okay, so that means essentially we are talking about 8n square, okay, less than 64n log 2n, right? So essentially for which n values this condition gets satisfied, we will take that n value, right? Now there are a lot of ways to solve this problem. Okay, but first let us simplify it first. Okay, so if I just simplify it a bit, okay, so if I just divide by 8 both of this side, so we are dealing with n square less than, as we are dividing by the positive number, right? So the sign will not be changing. So 8, so if I 64 by 8 is 8, then n log 2n, right? So now as we, okay, 8n log 2n. So now if we just divide by n both of this side, okay, so as n has to be a positive number because we are talking about the input size, right? So again this sign will not be changing, right? And we can divide, so this become n, like n square by n, and this is becoming 8 then log 2n, right? So now if I just solve this log over here, right, so this will become n less than, right? So whenever we just solve this log, this becoming log 2 n to the power 8, right? Because if I give this 8 over there, this to n, right? So now if I just now solve this log, so whatever the base this log have, it will go to this, n will go to that power to this base, that means 2 to the power n, right, less than n to the power 8. So this is becoming essentially this guy over here, right? So that means we need to find a way to find an n for which these conditions will be satisfied, right? So there are a lot of ways to solve this problem. Now we will try to solve it very logically, okay, and through programmatically as well. So if you see, when n equals to 1, right, so this left hand side is becoming 2 and the right hand side is becoming 1, right? 1 to the power 8 is 1. So that is not satisfying this inequality, right? But when from n equals to 2 onwards, if you see, it is left hand side is becoming 2 square, that means 4, and the right hand side is becoming 2 to the power 8, right? So that means it is satisfying this condition. Now we have to see till when this condition is getting satisfied. Okay, for that what we'll do is we will try to write a simple Python program, okay, which will help us to determine determine the solution of this problem. Because the ask here is to, for which values of n does the insertion sort beat the merge sort, right? So that means we need to find the values over here, right? So for that what I'll do is I'll go to this spider. Now in my system I am using Anaconda with Python distribution 3.6. okay, so if you just do not know how to install Anaconda and install Python with it, just let me know. I'll create a video for this one. Okay, so this is essentially a Python distribution. Now you can work with any Python version for this particular problem. This is very simplistic in nature. Okay, so what we'll do is we will start with n equals to 2. As we saw, n equals to 1, that inequality is not getting satisfied, right? And we will write a simple check, right? Okay, we'll say while, okay, that means we will going through a loop, okay, and we'll say this condition, if I just go back over here, 2 to the power n is less than n to the power 8, right? So this is how we check power in Python. 2 double star n, okay, less than n to the power 8 n double star 8. Okay, so we are checking this condition, and this loop is going, right, till this condition is getting satisfied. Okay, we will print this n over there. Okay, and after each and every loop iteration we will increase the n as well. So we can write something like n equals to n plus 1. Okay, so there are two ways to write this particular statement over here. Either you can write in this way, or you can write it in very short format called n plus equals to 1. Okay, so that means it will start from n equals to 2. So 2, 3, 4, 5, because we are increasing n for after each and every iteration, right? It will check this condition. If this condition is getting satisfied, it will go inside the loop and print n, right? So let us see how it is doing. If I just run this one, okay, it is asking me to save this. I'll just save it to my desktop over here. Okay, and click on run. If you see here, from 2, 3, 4 till 43, these conditions are getting satisfied. That means till n equals to 43, our insertion sort will take lesser step than the merge sort. After 43, it's the merge sort which will be taking lesser steps compared to insertion sort. Okay, that is what we are trying to solve. If you see, this is just a simple math problem over here, right? But the intention behind is like each and when you talk about an algorithm performance, right, whether measure it either by number of steps or how much time it took, right? So generally when you develop an algorithm of your own, you may need to do this kind of analysis. Okay, the intention behind this problem is like that only. Okay, so that means our problem solution will be n equals to 43. That means n equals to 43, that means 2 to 43. We'll better say n equals to 2 to 43, because we need to find the number of values over here, right? 43. The insertion sort will take or will beat merge sort. Okay, so we solved the first problem. We'll go back to the next one. Now next one is, what is the smallest value of n such that an algorithm whose running time is 100 n squared runs faster than an algorithm whose running time is 2 to the power n on the same machine. If you see, the first problem talks about the number of steps, the second problem is talking about the time over here, right? So we will try to solve in similar way. Okay, so I'll just make it bold. Okay, so essentially again we are talking about as same, like when a algorithm will run faster compared to any other algorithm, it's the running time which will take lesser time, right? That means essentially we are talking about 100 n square less than 2 to the power n, right? So now directly we have to find the n, right? Now if you read the question carefully, what it is asking for, it is asking for the smallest value of n over here. That is what we need to find it out, right? So that means if I go to my Python now, okay, so we will just remove this one. Now think about it, when we will try to write this program, I'll just clear the console over here as well, okay. We need to find the smallest value of n. That means whenever we got the first 10 which is satisfying that condition, we are done, right? So for that what we'll do is we will start with n equals to 1, because we don't know for which n this condition will get satisfied. So that's why we will loop forever. So if I just say while true, so whenever we talk about a loop, right, essentially what is happening, loop condition, we are either making it as true or false. Based on that only the loop gets executed, right? So whenever it's true, it is going inside the loop. Whenever it's false, it is going outside the loop, right? It is not executing the content of the loop body, right? So I am over here basically, if you say while equals to true, you are essentially creating a infinite loop over here, but we will control the loop execution very soon, okay? So then we will check something. We will check what? We will check this condition, if 100 n square is less than 2 to the power n, okay? So if here is the condition over here, right? So I am checking for a particular n, if I get 100 into n square, this double star is the square again, right? 100 n square, and single star is my multiplication operator, is less than, if I just go over here, 2 to the power n, right? So I will say 2 to the power n. So if we get a number which satisfying this condition, okay, we will print that number, okay, print n, and then we will come outside the loop, because this is what we want. The first number which is satisfying the condition, that has to be the smallest number, because I'll tell you why. This is how we will break the loop first, okay? We'll come outside. This is how we are controlling the loop execution over here, okay? And I will do n plus equals to 1. I'll increase n 1 by 1. So as we have started with 1 and increasing n 1 by 1 and checking this condition, if this condition is getting satisfied, that should be my smallest n, because after that there could be many a number of n's which will get satisfied, but as we have break it, that means the first number we are printing it, right, which is satisfying this condition. So that should suffice my problem over here, right? So let's see it, let's run it. If you see n equals to 15, that's the first number which is basically satisfying this condition, right? So we can say our solution of our problem is n equals to 15. So the smallest value of n is 15, for which an algorithm whose running time is 100 n square run faster than the algorithm whose running time is 2 to the power n, okay, on the same machine. Hopefully these two concepts are clear. Okay, we'll go to the next problem over here. Answer. I will make it bold. Okay. Okay, this question is asking us, apply the insertion sort algorithm to sort the array, this guy over here. Okay, so for that what I will do is I will try to create a table. Okay, it is not possible here. Okay, let us try to do it on our own itself. Okay, so we have this array over here, right? 31, 41, 59, 26, 41, 58, right? This array we have. Now the first step is we will always start with the second element over there, right? And on the left at the second element we will compare if any of these elements is less greater than this second element, we will shift it to 1, otherwise we will not shift that one, right? If you see 31 is greater than 41, no, so 31 will stay in its place, 41 will stay in its place only. Okay, so that means after first iteration I am getting the same array over there, right? Now in the second iteration, that means we are dealing with now. Okay, so I'll just try to color it out so that we can understand which element we are working with. Okay, I'll just make it as red. Now this is the third element we are working with, right? So now if you see it, 41 is greater than 59, no. 31 is greater than 59, no. That means after second iteration also we are dealing with the same array, right? Now let's go back to the third iteration. That means this time this should be black, this should be black, and this is the element we are currently working with now, right? So now if you see 59 is greater than 26, yes, so that means I have to make 59 one place there. Okay, 31, 41, so 26. Okay, we will shift all the elements, then we'll move to 26, right? So that means 59 will move to the fourth position, so I'll just write 59 here. Now this 41 and 58 will not make any changes because we are not working with them till now, right? So 59 moved to the fourth position. Now 41, again it is greater than 26, that means it will move to the next position as well. I'll just delete it. Now this 31 is again greater than 26, that means 31 and we will also move over there, right? And the 26 will be coming over here, right? So we place the 26 properly. Now we'll work with the fifth element over here, right? So I'll mark it over there, this one. So what will be my next iteration? In this iteration, now if you see it over here, 59 is greater than 41, no, but yes, sorry, so that means 59 will move to this 41th place. That means if I just make it comma, okay, so that means our 59 will be here and 58, which we still not worked on now, will be here, right? So now if you see it, this 41 is greater than 41, no, so that means the position where 59 vacated will be occupied by this 41, this guy, right? And the other guys, this 26, 31 and 41 will stay as is, right? I'll just copy it and I'll place it over here. Okay, so this is also done over there, right? So we did till the fourth element. Now the last element we will be working with, right? 58 over here, so I'll just mark it as red. So now if you see it, as 59 is greater than 58, so it will move to one place right side. Rest of the stuff are not greater than 58, they will stay as is, right? So that means in this step, this will be our final step over here, right? So I'll just copy it, this guy, place it over here. So this will be our 58 will move over here before 59, correct? And 59 will be my last element of this array, and I will just make this as black color. So this will be our final array over there, which is basically sorted. So we just applied an insertion sort algorithm to sort this particular array over there. Okay, so basically if you see, it is sorting from the less value to the higher value, right? Okay, we'll go to the next problem. Now in the next problem it is saying rewrite the insertion sort pseudocode to sort into decreasing order instead of increasing order. If you see, by default we are sorting by increasing order over here, right? Now we have to rewrite the pseudocode to sort in a decreasing order. That means from the higher term to the lower term over here, right? So we'll try to do that now. Okay, I'll just make it bold over here, right? So now for that we will just try to recap whatever we have done previously. In my previous lecture, if you have seen, I have developed this particular pseudocode for the insertion sort algorithm, right? So now we will try to implement the same stuff over here, right? There will be a very small changes, right? Now for that we will still loop from j equals to 2 to array dot length, right? So if I just mention a is my input array and a dot length is basically the array length over here, right? So that means we'll write something like this. So we will write for j equals to 2 to a dot length, right? So this is my for loop over there, right? So now first what we are doing, we basically keep the jth value, the key value, in a key over here, right? The way we are doing it for each and every element, we are storing it in a key, right? We will try to do that same thing over here, right? So if I just say key the similar way, whatever in insertion sort we have written, we will write it in a similar way. I will show you the difference. It will be there, key equals to aj, right? So after that what we have done over there is we started from the previous element of the j, right? That means I equals to j minus 1. We have taken that over there, I equals to j minus 1. If you just want to recap, you just go and recap the previous video I have created. I'll be giving that video link over here as well. Okay, so we started with the previous element, and then what we have done it over here is we created a while loop, right? So this while loop will be important over here. So this while loop is basically shifting the element over there, right? And while checking that shift, what we are checking is the ith element. That means the elements which is basically left hand side of the selected elements are greater than that key or not. So when we are basically talking about insertion default insertion sort algorithm, which is basically sorting the elements from the increasing order, okay, that means the smaller value will come first, the bigger value will come later. When we talk about the insertion algorithm, which will basically arrange the element or sort the element in decreasing order, that means the higher term will come first, only the changes will be happening over here in this term. Instead of ai greater than key, what we'll check? We'll check ai less than key, right? So that is what we'll be doing now. So while, okay, I greater than 0, this will always be there. This I is basically governing or basically running that loop, right? And I'll say ai is less than key now, right? That means ai is less than our key value over here, right? Then only I will be shifting it over there. And how I will shift like this. The similar way what we have done is like ai plus 1 equals to ai, right? So that means ai plus 1, okay, equals to ai over there, right? And what I have to do is I have to make this loop running, right? That means I have to continuously change this loop. So for that we have done I equals to I minus 1, right? So that is what we will be doing it now, I equals to I minus 1, right? So this is the loop. So this loop is basically shifting that element and making proper space for the new element, and the new element will be stored. So this is my end of while loop, right? So this is my end of while loop. After while loop is end, we have to place the element by using the same code. A ith plus 1 will be always empty. I have explained this stuff why it will be I plus 1 in my previous video, so you should check out that one. Okay, so a I plus 1 equals to key, right? So this by using this statement, we are basically placing that key value over there, that element over there, right? Selected element, then end for, right? So this is what the pseudocode will be when we basically wanted to write a insertion algorithm in a decreasing order. Okay, so hopefully this is clear. This is fun. Okay, so we will just go to the next problem now. And don't worry, I'll be sharing this answer sheet as well, so that you can refer it in my video link. In my video description, you will find a GitHub link over there. Okay, so you can download it from there. Now this is an interesting problem. So this is basically, here we will be writing a new pseudocode. Okay, so consider a searching problem. Okay, we have an input of sequence of n numbers, let's say a1 to an. Okay, and we have a value, let's say v. Okay, now our job is to write an pseudocode, basically an algorithm. Okay, what we'll do, the algorithm output will be the index I such that v equals to ai. That means if we find this v into this array, we have to return the index of that element. Index means the index of first element will be 1, index of second element will be 2, something like that. The position of the element over there, basically. Okay, if we are not able to find that element, we have to return nil over there. Okay, if v does not appear in a, so you have to write a pseudocode here. So let us start with, so what we'll do, let's say we will keep I as our index, and we will always initialize I with nil. Okay, so that means we are starting our I with nil. Now what we have to do is, if we just take this approach, we will just loop through each and every element of this particular sequence and check whether it is equals to v or not, right? So that's why we will write a for loop here, right? So for here, let's say loop counter, I will say j equals to 1 to a dot length. If I say a is our, okay, it is already mentioned over there in the problem as well, a is our array name over here, right? So we will loop it. Now inside the loop, we have to check whether an element, that jth element of a is equals to v or not. So this is how you check. If a of j, okay, a of j equals to v, okay, then only we have to take the index of that j and index of that element, but that is index is already j, right? Because j is my index over here, right? So that means we will be returning, or we will make the value of I as j, because this will be our ultimate goal, right? To get the index of that element, and we will return I, right? This is how we return something, or we'll send some value out of that program, right? And then we will say end if. This is where our if will be end, and this is where we will end for, and ultimately it will just return I over there. Okay, so this is the pseudocode for to find an element which is basically a part of an sequence or not. Okay, so this is the pseudocode for that one. So hopefully it is intuitive enough to see like this particular algorithm works over there. Okay, we'll move to the next one. I'll just make it bold. Now what is this problem is telling me? Consider the problem of adding two n-bit binary integers, okay, so stored in two n element arrays, right, a and b. Now the sum of these two integers should be stored in a binary form, okay, in an n plus 1 element array c, right? That means if I just sum these two the n bit binary integers, that means n element arrays, it will create an output of n plus 1 element array, because the carry will take another bit over there, right? Now state the problem formally and write pseudocode for adding those two integers over there, right? So let us try to write a pseudocode for that one. So when we add binary numbers, what we do, we add bit by bit, and where we start from the end of that binary integers, right? That means if I just say 1 1 1 plus 2 2 for plus 0 0 0, so basically we are starting with nth element. From left to right we move, sorry, from the end to the beginning of that array we move, right, one by one. So for that, what we'll do is we'll just initialize the carry equals to 0, right? So when we'll add the nth element of that array, it will be we have to add the carry as well, right? So this is how the binary addition works, right? You know what, let me give you an example over here. So if I just say 1 1 1, okay, and plus 1 0 1 1 0, let's say. So what will be my output over here, right? So first we'll start with the rightmost element over here, right, of this two digits over there, right? It's if I just say this 1 and 0 are stored in bit by bit, okay, of an four element array A. So this essentially, this is my A and this is my B, right? So I'll just try to add this 1 and 0 first, and if there is any carry from the previous addition, we have to add that one as well. Suppose 1 0, so this guy will become 1 over here, right? So then I will add this 1 and 1, right? Previous carry is, there is no previous carry. The carry will be always when it is greater than equals to 2, right? So that means this is, if I just say this 1 and 1 will be becoming 2 over here, right? That means 2 means in binary is 1 0, so this will be 0, right? This will be 0, so I'll just make it similar way, okay? So and my carry will be 1. This carry will be added to these two guys as well, right? So 1 plus 0 plus carry 1, that means again it will become 2, which is basically 0, right? And there is another carry as well, which is 1, which will be adding to over here, right? That means 1 plus 1 is 2, and another carry is 1, that means 3. It will become 3 is 1 1, right? And there is an extra carry over here. If you see it, it will be added over here, right? So that means if we add two 4 elements of array, okay, binary with binary digit, if I say, so it may happen that it will create a n plus 1 element of array over there, right? So this algorithm we have to build now. So we'll start with carry equals to 0, right? So we have to loop through all these elements of this array and then add it, right? So for that, what I'll do is we'll create a single loop now for I equals to n, because we will start from the last element of this array, not from the first element, right? So I equals to n to 1. If you see, till now we have seen an example of proper looping, right? So this is normal looping from 1 to the n. We are looping through. That means from the first element to the last element of the loop. Here by this one we are basically looping through from the last element to the first element of the loop, okay? So 2 1, right? So now what I have to do, so if I just write something like C I plus 1, let me I'll explain you why it makes sense, okay? That means I'm talking about what if I equals to n, I will be writing the if I equals to 2, I will be writing the third element of the C. Okay, something like that. I plus 1 equals to, okay, A I, okay, plus B I, okay, plus the carry over here. Okay. Okay, so let me explain you why I have written this one. If you see, if I just take this example over here, right? So both this 1 and 0 are the fourth element of A and B respectively, right? Now when I am adding this 2 and writing this 1 over here, this is essentially becoming the fifth element of C, right? Because this A and B can introduce a carry which will be the last, basically the first element of the C, right? So that's why I have given I plus 1 over here, right? Whenever we'll be adding AI and BI, we will be always creating the C I plus 1th element over here, right? Now what I have to check, we have to add carry as well, because there would be a possibility that a carry will be there as well, right? So I'm saying we have to manipulate the carry now. So if I'm saying if, okay, AI plus BI, okay, greater than equals, okay, plus carry as well, the previous carry basically equals to 2, then I'll say carry equals to 1, right? Because we are always taking a 1 over there. Carry equals to 1. Otherwise, this is the else part of it. Else carry equals to 0, right? So if this sum is producing producing a result greater than equals to 2, then only we are taking a carry of 1 to the next sum. Otherwise we are taking a carry of 0 over here. If you see, the fourth element of A and B was 1 and 0, which was basically less than 2. That's why when we were adding the third elements, we were not adding this carry over here. That's why basically not adding means we are adding a carry of 0 over there. Okay, so then this is our end if, right? So this loop will go from last element till first element, it will add, right? Now at last, when everything will be done, the first element of the C will be the carry one, right? So we have to do that one. So we have to end the if, end the for, okay? After addition of all this one, we will say C1, okay? That means first element of the C will be the carry coming out of this loop, because we don't know what will be our last addition of it, right? That means the first element of A and B, if they are producing carry, we will keep it as 1. If they don't produce any carry, it will be 0, right? That means it may possible that this if A or B are both 4 elements array, it can produce 4 elements result as well based on this carry, right? If the carry is 0, then it will be a 4 element array over there, right? Because this 0 does not make any sense, right? So it will be carry over there, right? So this is the pseudo code for an algorithm which is basically adding 2 n-bit binary digits and creating a n+1 element binary digits, bit binary digits basically. Okay, so hopefully this problem solvings are useful. In future videos also, whenever we discuss a lot of other algorithms, we'll try to solve a lot of problems as well over there, and mostly I'll be taking this problems from Cormen books. Okay, see you in next video.